I did cut the tape earlier, and I just taped over the address and stuff, but I haven't looked in the box yet. This battery is supposed to be a 4 amp hour with a segmented display. Nothing else, no documentation in the box. Okay, so it is a 4 amp hour, and we do have the segmented display. Flashing red. We never want to see that, but 2022 jackpot. So the first thing we do with a new pack is check the voltage at the terminals. And I have this handy dandy little adapter that makes that easy to check. Let's call that 45.5 for the sake of discussion. So we said the total pack voltage was 45.5. Yeah, no, I can't write. Alright. And to get these packs apart, and ultimately all the goodies are in here. This is what we want to get into, but that comes off last because it's usually hard to get off. We'll take these screws out. Now, we've got some cell monitoring terminals back here, but we cannot measure a single cell since we can't get to the other end yet. But we can measure 2 cells, and the most we can get is 6 cells. Hey Siri, what is 45.5 divided by 14?
45.5 divided by 14 is 3.25.
3.25 times 2 would be 6.5. So we've got 6.8, 20.5. That'll be 6 cells.
20.5 divided by 6 is approximately 3.4166.
And that's 6.8. So that bears out 3.4. All right. This says the cell should be at 3.25, but we're getting 3.4.
3.4 times 13 is 44.2.
And we have 45.5. So that leaves us with one cell group that should be at 1.3 volts. So now we're going to take this the rest of the way apart. And the next ones I'm going to take off are these. And I keep all the screws with a magnet. And as a general rule with these BA2242T packs, I usually can't get this one off yet. What I found the easiest way is to get all the screws out. And this one's popping off, but usually they don't. And when you rip it off, you take a chance of tearing a bunch of wires in there. So how I usually get it off is take all the screws out and then pry this up, and that always pops this one end loose here. Okay, so we can get in here, and with these BA2242T batteries, they put a lot of silicone goo on the wire connectors, and these wires seem pretty damn short on this one. We're going to pick the goop out of there and undo the connectors. Okay, so it seems like every one of these I tear apart, they got more and more goo in them with every one. Look at that. That just popped up and pulled the connector right out. There's 2 more connectors down there. Let's see if we can get those loose. Alright, this is one to come off all in one too, but I'm afraid of tearing anything. Alright, yep. All in one, but it's okay, we didn't break nothing. Alright, so far no damage. I can check the individual cell voltages from here, but it's easier with the BMS connected and using the test points. They glue these in the bottom too. They put glue in and then they smash the batteries down, but I'm not prying on the cell here. I'm going to pry on this plastic shell. Alright, let me pop the glue seam loose. These wires are routed differently than they used to be, and I don't like it. They used to be all in one bundle. Now they got them coming up from several sides. And look, these things are still sharp. They don't look like they've ever been even warmed up.
3.4 times 7 is 23.8.
Let's see if that's what we have. Alright, so that's, and we had a little more than 3/4, so that's good. So this whole side is good. We know our low cell is over here. God damn. Did they use enough shit on here? Okay, so we got all the little test points exposed for the cell monitoring. Now they're harder in these batteries because they're not labeled, but from older batteries that I've worked on, you know, we know that these are test points 1, 2, 3, 4, 5. To go up to 7 on this side, and to go from 8 to 14 down this side. We're going to plug the battery back in and see if we can't determine which one is the low cell that way. And yes, this is effing tedious. One back in. I'm going to start from the main battery negative, which is over here. The test point for cell 1, 3, 4. Okay, and we're just going to chase these fellows on down the line. 3, 4. 3, 4. 3, 4. 3, 4. 3, 4. There it is. B7. 10 volt. Oh man, that's, wow, I don't know. Is that worth saving? Or trying to save? Or should I just rip that group out? Alright, so what I am going to do is access the leads for B7. And I believe one side to be right here. And I can check that. You know what? I'm going to take this off of here. It's a pain in my ace. Now, what puzzles me is what's causing these individual groups to go low? Is there a bad cell in that group? Or is there a part in the monitoring? Alright, so I can see one side of that. And I might be able to clip to it. There it is. Okay. So we've got access to these cells. I'm just going to put this little clip on my other probe. And I'm going to let you guys see. That's never going to focus in there. Alright, I was really lucky that I didn't have to pick these packs apart. But I've got this lead connected to one end of that cell group, and this one connected to the other end of the cell group. So I'm going to unplug the leads from my meter now and plug them into my power supply. Now in this power supply, this is not ground. This is specifically for battery charging. And if you look over here, that's reading the 1 volt that we have. So, and I want to set this thing for 3.4 volts, but I want to start this charge really low. And let's see if we can bring this thing back up. We're up at 2.5 volts now. I'm going to set the current. And I'm also going to keep an eye on these fellas, make sure they don't show any signs of temperature. Okay, the power supply says that cell group is done charging, but we're going to double check it. 3.4. Alright, so let's measure one of the other ones just to be sure. 3.4. So they should be all equal now. Let's see what we get here. Hey Siri, what is 3.4 times 14? Siri says we ought to get 47.6 volts. Well, we had a little more than 3.4. It was 3.4 and change. Okay, so this thing ought to be fixed. We're going to put everything back together, make sure the lights are behaving properly. Then we're going to put it on a charger, make sure that is what it's supposed to be. And then we're going to cycle this thing a couple times and then open it back up and make sure that this thing is behaving itself. So this single cell group going low seems to be a common problem with these things. All right. Well, this has to go back on to cover that cell monitor spot. This one has to go back on. Oh, these things are a pain in my ass. Okay, that one is seated. And we don't want to let none of these little contacts touch anything around in here. One more to go. Okay, that is seated. Let's see what happens. Alright, let's go get the charger. Okay. Okay, this light turned green. Okay, so far so good. I'm going to pull this off and put this thing back together and start doing some discharge and charge cycles. We got her charged up. Now we got to take the stuff back out of it. I don't like to waste electricity. I'm getting the power out with this power adapter. I'm running it through this meter so I can just keep an eye on things, the voltage. And then I'm using this converter to buck it down to 27, 28 volts because the max that this can take is 28 volts. And with that, I'm running my computer and keeping this iPad topped up. And right now, this method is a little too slow. After this depletion, on the next charge, I'll use it to charge my camper van batteries. Okay, we cycled this battery 4 times. Got 47.6. It's recovered quite a bit from earlier. It was flashing red earlier. Now it says I've got 4 bars.
47.6 divided by 14 is 3.4.
Okay, so this should all be at 3.4 volts. I'm going to pull this connector out so I can lay that down. The one that was low before was group 7. Let's just go ahead and do them all for fun. 3.4, 3.38, 3.34, 3.36, 3.42. Oh, that's group 7, 3.31. Alright, that was the low one before. Group 8, 3.3, 9, 3.4. Group 10, 3.3. 11 is 3.4. 12 is 3.4. 13 is 3.3. So I'm going to put this one back together. Alright, so I'm going to charge this up. And then I'm going to measure all of these again. I think I would like to make up a connector for these things that I can just plug right into the pack monitoring connectors and balance single groups that way. Okay, this battery's been charged up. It's been sitting a few days. All right, we're sitting at 57.8.
57.8 divided by 14 is approximately 4.1285.
So the magic number we're looking for is 4.1. Preferably dead on 4.12. And I finally broke down and bought me some fine point probes. We'll just start right out with the problem child. 4.1. 4.1. What's this? 4.11, 4.15. That's not terrible. 4.12. All right, let's check some on the other side. 4.12. 4.12. 4.13. 4.12. So this one might be a little weak. Most of them are reading 4.12. That's 4.11. All right, but I'm calling that good. So this was a success in my book. I got a few more problem children floating around, and I'm about ready to start robbing parts. Keep coming back and we'll see what else we get into.